In this video, we present several examples of our sketching framework. Sketch Analyzer is a sketch interface based on recognition that is designed to achieve the highest level of robustness. Our work focuses primarily on the problem of stroke classification. The examples are designed to highlight the effectiveness, flexibility, and robustness of our approach. We also present an application of our work for driving facial expressions. In this example, we introduce the main features of the Sketch Analyzer. A stroke is being recorded at each continuous motion of the mouse or stylus. A sketch is composed of a large number of individual strokes as shown. Sketch Analyzer computes several shape attributes for every stroke as it is drawn. Shape attributes quantify aspects of a stroke that are visually relevant. Shape attributes range from generic to detailed. A comprehensive description of shape attributes is given in the paper. Shape attributes are used to train a support vector machine for classification. During training, strokes are labeled manually by the user. For basic sketches, 10 training examples are sufficient to produce reliable classifications. In this example, the Sketch Analyzer was trained on the main components of a face. The trained support vector machine is used to classify the sketch. Shape attributes quantify strokes at many different levels of granularity. However, our results show that generic shape attributes are sufficient to obtain reliable classifications. In this example, we show how stroke grouping can be used to achieve robust classifications for cluttered sketches. In this example, the eyebrows are drawn with multiple disconnected strokes. The mouth contains teeth, which are not found in the training set, and there are also several spurious strokes within the mouth. A successful classification of a sketch would not be possible without properly grouping the strokes. Our algorithm explores the space of possible groupings and selects the grouping that results in the best classification. This is accomplished by ranking classification results based on heuristics. The sketch is classified successfully. A structural grouping is used for the eyebrows, and a grouping based on overlap is used for the strokes associated with the mouth. Notice that pupils are not grouped with the outline of the eyes based on overlap. Our algorithm detected that a better classification results if it does not group the eyes with the pupils. In this example, we show the robustness of our approach against outliers. Here we train the system on the components of a house. The classification labels are shown. In this example, there are several outlier strokes that are not part of the training set: the smoke, the window grille, and the vertical bars on the door. Again, the classification is successful. Notice that the classification was achieved by grouping outliers with other strokes, such as the chimney with the smoke. Although these groupings may not always be semantically meaningful, they provide robustness against outliers and enable the classification to be carried out successfully. In this example, we demonstrate the interaction between the training set and the grouping of strokes. In this case, the door handle is not part of the training set. The classification is successful. The door and its handle were grouped together since the training set does not recognize the door handle. The same training set was used both for this and the previous example. Notice that our classification technique can robustly handle different drawing styles. We now extend the training by adding an additional label, the door handle. We run the classification again on the same sketch used previously. In this case, the system automatically accommodates the expanding training set by generating a different grouping. Notice that now the door handle is not grouped with other strokes and it is labeled correctly by the classification.